Hi, in this video we're going to be looking at trigonometry, and our focus is on grade 11 two-dimensional problems. So we're going to focus on our first question, which appeared in the November 18 paper. And the question reads, in the diagram below, angle DCB, the small angle is alpha, AC, that's our side, is h units, and angle ACB, that's the big angle, is theta. The first question there is to determine the size of angle ACD. And if we look at the triangle ACD, we're trying to find the angle. All we have to do is subtract theta, subtract alpha, and here we have it, and we have the angle ACD. The next question is to prove that AD is equal to h sine theta minus alpha all over cos alpha. At the first glance, that looks quite intimidating. So let's look at it in the diagram. So we have AD, and the question we ask ourselves, do we have the angle opposite AD? So we have, or we found, the question is to find AD. Well, we have the angle opposite AD, that's good news. And if you zoom into the question, you'll notice that H is present. So we want to look at H, and we need the angle opposite H. And if we have the angle opposite H, which is D1, then we can use the sine rule. So let's try and find D1. So if we focus on angle D1, you'll notice that angle D1 is actually the exterior angle of triangle DCB. So in other words, I can use alpha and 90, and if I add both, I would get angle D1. And there we have it, 90 plus alpha. And the reason is quite simple. If I were to write that down, angle D1 is equal to 90 plus alpha. And our reason would be exterior angle of a triangle. So if we have that angle, we can now use the sine rule. And the sine rule dictates, remember we're trying to find AD, over sine of that angle is equal to h over sine of 90 plus alpha. So let's put that down. So we have AD, as you can see, over sine of theta minus alpha is equal to h over 90 plus alpha. Now, if we examine this, you will notice that we have a fraction and we can cross multiply. But before we do that, we also notice that sine of 90 plus alpha, and we can use co-ratios, complementary angles, and change that sign to cos. So we have AD over sine of theta minus alpha is equal to h, and I've changed sine to the complement, which is cos alpha. Next, we're going to use an LCD or cross multiply. AD times cos alpha. So we have AD times cos alpha is equal to h times sine of theta minus alpha. And then to solve for AD, we're going to divide both sides by cos alpha. And there we have it, AD dividing by cos alpha, dividing by cos alpha. We have h sine theta minus alpha all over cos alpha. And that is what the question actually wanted. The next question is determine, and I just want to put this into my diagram. So the question is to determine the length of AD if H, so they're giving me H to be 17, let's put it in there. Theta is 58, so the big angle is 58. Alpha is 23. So to find the angle in between, we're going to take 58 minus 23, and that'll give me 35 degrees. So we know this angle inside there is 35 degrees. So the question is to go and find AD, and all we have to do is actually substitute. We have H to be 17, and we have theta minus alpha, which is 35, and we got cos of alpha, which is 23. And here we have it by substitution. 17 sine 58 minus 23, which I worked out for you to be 35 all over cos 23. And we can type that on a calculator. Type that on a calculator and it should give me AD is equal to 10.59 units. I just want to clear my diagram out. Next question we have is to calculate the area of triangle ADC. If we're looking at ADC, and to find the area of that triangle, we're going to use the area rule. And we need to look at what sides we have. Very important. So we just found AD to be 10.59. Okay. So in using the area rule, we need two sides, which we're going to use 17 and we're going to use 10.59. So we need to find angle A. And that's quite easy because we know that this angle was given to be 58. Angle B is 90. Using some angles of a triangle, I can find angle A to be equal to 180 minus 90. And then we're going to take the 90 and we're going to subtract the 58. And that gives us 32 degrees. So we can find angle A to be 32 degrees. And now we're going to use the area formula. And the area of triangle ADC would be equal to half AD. We have AD times AC. We have AC times sine of angle A. And all we have to do is substitute the values. Half times 10.59 times 17 times sine of 32 degrees. And we can type that on our calculator and it should give us 47.70 units. Hi, in the next question from November 16, it says quad ABCD. As you can see, we have a quad drawn for us. BC is 235 in the diagram. AB is 90.52 in the diagram. It is also given that angle ADB is 31.23, DAB 109.16, and CBD is 48.88. So we have a lot of information. The first question is to determine the length of BD. So we're going to highlight the triangle that has BD and lots of information in it. And the first thing that comes to mind is the sine rule. So let's see if we have enough information to use the sine rule. So the question is to find DB. We need the angle opposite. Correct, we have that. And we need one more side and the angle opposite it. So we have enough information to use the sine rule. So we're going to start with what we're going to find. And we will say BD, as you can see, over sine of 109.16 is equal to 90.52 over 31.23. So we are using the sine rule. And from there, we can, before we go to that step, we can cross multiply. And if we cross multiply, we have BD times sine 31.23 is actually equal to 90.52 times sine 109.16. And then to find BD, we're going to divide by sine 31.23, both sides by sine 31.23. And then we can find BD, which I have on my PowerPoint. And then you can use your calculator and you can type that in, and you would get 164.92 meters. And we would like to put that on our diagram because surely that should help us with the next question. Okay, the next question wants us to find CD. All right, and if we look into our diagram, we're trying to find CD. So we have CD. Sorry, my mistake, that's CB. We're trying to find CD. And there's our side CD. Now, if you try to use the sine rule, CD, we have the angle opposite it. But we have two sides and we don't have any angle opposite the two sides. So, if you look at what's given in this diagram, we have two sides and an included angle. We have side DB, we have side CB, and we've got an included angle. And that dictates the cos rule. So the cos rule states that CD squared would be equal to BD squared plus BC squared minus 2 BD times BC and cos of the included angle, which is 48.88. And all we have to do is substitute from the diagram. We're going to get CD squared is equal to BD squared will be 164.92 squared plus BC squared is 235 squared minus 2 BD, which is 164.92. Then we got BC, which is 235, and then we're going to say cos, I'm going to my diagram, 48.88. And that we can actually type on a calculator. Just want to clear this out. If you type that on a calculator, and you would get CD squared is equal to 31448 point, and we don't want to round off as yet. We'll round off in the last step, and then we can square root that. And if we square root that in our calculator, we should get 177.34 meters. And that is a question that uses the sine rule and the cosine rule. Hi, we're going to look at the question that came out from the November 2023 paper. And it reads as follows. In the diagram, P, Q, R, and S are points on the same vertical plane. The angle of elevation of R from Q is alpha. Well, we see it's in the diagram. And the angle of elevation of Q from S is theta, which is in the diagram. It tells us that PS is x units. It's in the diagram as well. I just want to highlight on that. And QRS is equal to beta. And the question is to prove that SR is equal to x sine alpha plus theta all over cos theta sine beta. Sounds quite intimidating once again. So I see there is two triangles. So I want to just separate that so you can see there's a red triangle and there's a black triangle. So in a question like this, where do we start? I'd like to start with the question actually. So if we're trying to find SR, I'm going to go with the sine rule. and say SR over the angle there, which is alpha, and Q1. Now, we can find Q1 if we look at this triangle that we have here. Okay, if we're trying to find Q1, because of alternate angles, Q1 is actually going to be theta. So write that down. So Q1 is equal to, my pen, theta, because of alternate angles. So we have, just to point that out again in case you missed that, we've got an alternate angle theta equal to the angle at S, theta, and that's alternate angles. So very quickly we can make a statement that Q1 is equal to theta, and we have reason would be equal alternate angles. Okay, so we can see that, and together this angle is alpha plus theta, which I want to make a note of. Or we could say, so the entire angle that is there, that is RQS, is going to be, and I'm going to write that down as well, that angle RQS is actually equal to alpha plus theta. So to carry on with my sine rule that I want to use, I'm going to say SR over sine of alpha plus theta is actually equal to, and then I'm going to use QS because I have beta, and also QS is a common side, which is QS over sine of beta. Now, to solve my problem, if I find QS, that would make life very easy for me. So let's quickly cross multiply. We're going to get SR times sine beta is equal to QS times sine of alpha plus theta. Now the problem that I have when I solve for this, I'm going to divide both sides by sine beta. Okay, so the problem I have, as I mentioned, is that I need to find QS. So we go back to the triangle, just to create some space. And if we look at QS, we can find QS using trig ratios, because the red triangle is actually a right angle triangle. And if it's a right angle triangle, well, we can even use the sine rule if you want to, since we're operating on the sine rule, just to make life a little easy for you. So you can use your SOHCAHTOA, or you can actually use your sine rule in terms of finding QS. And we would get QS over sine 90 is equal to, and we're going to use X because it's given, and we need the angle opposite X, and we can use some angles of a triangle. In the red triangle we have a 90, we have a theta, and using some angles of a triangle, this angle here at Q would actually be 90 minus theta. So we're going to have X over sine of 90 minus theta. Now we know sine 90 is 1, so you got QS over 1 is equal to X, and sine of 90 minus theta is actually cos theta, using complementary angles. We can cross multiply. QS times cos theta is equal to X, and therefore dividing both sides by cos theta, we come out with QS would be X over cos theta. And what we're going to do is replace that. then SR is actually equal to, now QS we found, let's put it in red, it's actually X, and we can put it in the bottom because we are multiplying, and on the top we have, from the original, we have, sorry, pen is jumping a little. Okay, on the top we still have sine alpha plus beta, sorry, theta, and in the bottom we still have the sine beta. And if you look at it on the top, that's actually what they wanted us to find. Thank you.